You can work on homework on your own time. I get paid huge amounts of money to instruct you. So let's use this time and let me instruct you. And then you can do all that homework on your own and check the answers up here if you wish. So, here's what I need to know from you. What am I doing? Raise your hand and say something to me, and I will do whatever you want me to do. Lucy.
Can you do 3, 2, number 3?
We're talking about homework 3-2.
Yeah.
Number 3. Write the equation of a logistic function. Am I looking at the right problem, Lucy?
Yes.
Write the equation of a logistic function. So the first thing that has to pop through my head is, what in the world does a logistic function even look like? So the form that we are using, the form that we practice, the form that we're using is y equals a over 1 plus bc to the x. Remember that? That's our logistic function. We are told that the initial value is 16. We are told that the maximum sustainable population, otherwise known as the limit to growth, is 128. And some random point on the curve is the point 5, 32. All right? Now, of those 3, there is one that you can just stick in. Which one can we just stick in? The limit to growth. We know the limit to growth is right there. As long as that number's a 1, that's going to be your upper asymptote every time. Okay? And since I'm building the equation, and I'm building it with a 1, that's going to be my limit to growth. So y equals 128 over 1 plus bc to the x. All right? Now, remember that just like with exponentials, the initial value is the value of the function when x is 0. At the beginning, when x is 0. So this is the same as the point 0, 16. The initial value is always the y-intercept. Okay? Now, none of those letters are the initial value. It's not like in an exponential where you can just plug it in. But if x is 0 and y is 16, I think we can figure out another one of our letters. Right? Because what happens to this?
1.
It's gone. So 16 equals 128 over 1 plus b. So 16 plus 16b equals 128. If I multiply this over here. So what's 16b equals, what is that, 112? So what's 16 into 112? 7? 7? So now I know b is 7. So then back to my equation, y equals 128 over 1 plus 7, c to the x. So now I'll take my random point, which says if x is 5, y is 32. So 32 equals 128 over 1 plus 7, c to the 5th. So bringing this over, 32 plus 224, c to the 5th equals 128. Keep an eye on my arithmetic. So 224, c to the 5th equals, what is that, 96? So c to the fifth equals 96 over 224. I don't think that's a fifth power, so we're gonna have to do some calculator work here. We're gonna have to take the fifth root of that. So 96 divided by 224 raised to the 1/5 power. I got 0.844. Anybody else get that? That's right. So my final answer, Lucy, after all that, is 128 over 1 plus 7.844 to the x. Okay, Lucy?
I think so I got the 224, c to the fifth equals 96. And then I think I took the fifth root of both sides.
You can do that.
Why did I set that? Oh, wait. Oh, because I didn't take the fifth root of 224.
Okay, well, I can do it.
Never mind.
Yeah. I would divide first, but you can do it the way you did.
I did the same thing, but for the bottom, like I multiplied 7 and 8.844 together. Is that wrong?
Totally. Totally. These can't be multiplied because this doesn't have an exponent and that one does. We never combine those two numbers. Look, Maren, look. In the formula, are they written as one number?
No.
No. They're two separate numbers.
Oh, I have another question.
I'm ready for another
Okay.
question.
On homework 3.5,
3.5.
letter E.
11.
No, E, letter E.
Letter.
Oh, that's a good one.
Wait, can we grab them when we're done?
Okay.
Yeah, if you want to grab it out here, you can. Please don't mess them all around and get them all, like, don't put them on the floor and stuff. Just be careful. Messing with other people's papers.
You see Mark, you be like,
Alright, I think I'm doing. You could just write the problem down on another piece of paper. Alright. So we are solving a logarithmic equation, and it tells me I'm to use my calculator only if necessary. So, I don't know, this looks very bad. Let's see. Here is the deal. When you are solving a logarithmic equation, you cannot have more than one logarithm on either side, period. Period. No more than one logarithm on either side. So right here, oh wait a minute. First of all, I think I'm gonna divide the whole shebang by 3. That is completely legit because these guys are coefficients, right? So you don't have to do that, but it's gonna make my numbers a lot more manageable. Remember, see that 3 right there? He's a power. I do not wanna mess with that. If I can get rid of it, I'm gonna get rid of it, so I'm gonna divide it by 3. Then, I'm going to have to put these two together. Now, when I put them together, they will go together as an add, subtract, multiply, or divide. Multiply. So ln x squared minus x minus 6. I am FOILing these two. That tells me that when I condense, I'm going to multiply these together, so I think I FOILed correctly. On this side of the equation, there is nothing to do with that 5 except pop him up as an exponent. So that's ln 32.
What happens to the 3?
I divided
The
every
5 by 3.
It's a 15.
Yeah, well, I wasn't sure. You don't touch the 2?
No.
No, because the 2 is not.
Okay. Now,
Yeah,
as soon as you get to this point where you have logarithm equal logarithm, these can be disregarded, and now you are going to solve this equation. So, it looks like I'm gonna have x squared minus x minus 38. Now that does not factor, right? So I'm gonna use my quadratic formula, Mr. Fahey.
I was gonna ask if from the beginning you could just take out a 3 and from the very start. Could you divide everything by 1 and 3?
ln, you can't, take your calculator and do 15 divided by ln, and tell me what happens.
Well, I assume it doesn't work.
Yeah, ln does not exist without a number. It has to be ln something. Now, can you divide by ln 18? Absolutely, but you cannot divide by ln by itself.
So you couldn't cancel out the ln's.
No, listen to me. You cannot solve a logarithmic equation unless you have reduced it to the point where you have no more than one logarithm on each side. There's no way to get rid of the logarithms if you have more than one on each side. Can't do it. Don't try it. Right? It'll get when I grade it, right? That's what's gonna happen. That's what's gonna happen. All right. Quadratic formula. Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 1 plus 4 times 38. Square root of 153. Now, these are the two answers, but I want you to be careful. What happens when we do 1 minus the square root of 153? It's negative. Go back to your original problem. Can x be negative? No, because that would mean taking the logarithm of a negative, and that is not allowed. Okay? So the only answer to the problem, if you left it exact, the only answer to the problem would be that one. Now, if you typed it in, I have no problem with that. So 6.68, if you got it decimally, 6.68. Okay, Lewis.
2B on the calculator.
All right, so now I'm looking at my review sheet. The calculator part, 2B. All right, so Lewis wants to do one of these bad problems. These are the big bad problems. I remember this. He says, yes. All right. So how do we start?
Multiply that.
Multiply by 4. So 2 to the x minus 2 to the negative x equals 12.
I'll take the one.
Now the next step is kind of counterintuitive, because you just said I'm gonna clear that fraction, but now we're gonna turn around and make another fraction. So 2 to the x minus 1 over 2 to the x equals 12. Now we're gonna get rid of that fraction. So multiplying everything by 2 to the x, I'll have 2 to the x times 2 to the x minus 1 equals 12 times 2 to the x. Right? Now, when you multiply something by itself, that's the equivalent of squaring it, right? This is 2 to the 2x. Add the exponents. It's 2 to the 2x. It's 2 to the x squared. Minus 12 times 2 to the x minus 1. I'm moving everything over and getting 0. Right? Now, some of you can look at that and say that's quadratic. I'm going to factor that. or I'm gonna use the quadratic formula on that. If you can't, I mean, it's a little confusing, so think of this as a letter, like u squared. Minus 12u minus 1. Now, when you look at it like that, you got it, right? It doesn't factor, but we can certainly use the quadratic formula. So u equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's 12 plus or minus the square root of 148. Right? Now, let's not waste time simplifying that. This isn't the answer. Right? 2 to the x is that. So 2 to the x equals 12 plus the square root of 148 divided by 2, which is 12.08. I'll carry a few more decimal places, 2.8. Or 2 to the x equals 12 minus the square root of 148, which is negative 0.0828. So those two numbers are what we get when we solve that quadratic. But we got that quadratic by letting u be 2 to the x. So 2 to the x is that, 2 to the x is that. How do we solve those? First of all, that one's not possible because you can't raise 2 to a power and be negative, right? So we'll log both sides here. And our x value will be the log of that divided by the log of 2. So I got 3.59 as the only answer to the problem. Lewis, what do you think about that? That's what you got? Well then, life is good.
Did you do 2C on 3.3?
Homework 3.3 2C.
Yeah.
Karen, what did you do?
I just said like 5 to the power of 6 equals x, and my answer
What did you do with the 3?
multiplied it by value for x.
No, because that 3 isn't a multiplier. Once you change that into, once you do 5 to the 6th equals x, you treated this as a logarithm, and this is an exponent. So if you're gonna do that, which I would never recommend in a million years, but if that's how you're gonna do the problem, it's 5 to the 6th equals x cubed. I would just divide both sides by 3 and do 5 squared, so the answer's 25. Right? When you start rewriting logarithms, you can't have a number out in front unless you have rewritten it as an exponent. Right, someone had a hand up over here. Lucy? Your next test, I didn't know it was Lucy, and she's already asked one, go ahead.
For 3.5, for f, you just said that you can't have 2 to the x, or 2 raised to the x and it be equal to negative, but you wrote my paper x equals negative 2.543. Because I had my answer as x equals 2.543, and you wrote x equals negative 2.
Okay, but that one, okay, okay. Lucy, you solved it, and you must have done it correctly because you got 2. So you ended up equaling 3 plus or minus 2 root 2. those were our U values. Okay, so one of those are 3 plus the square root of 8. So one of those is 5.828. So was it 2 to the x? So 2 to the x equals 5.828, right? And then 3 minus the square root of 8 is 0.1716. So 2 to the x equals 0.1716.
I got it.
X is an exponent. Can exponents be negative?
Yeah.
Absolutely,
They
absolutely.
just can't equal.
You can't raise 2 to a power and get a negative. All right? Now, Tess, what do you want? Okay, Sabrina? Are we on the calculator review or the no calculator?
No, the no calculator.
No calculator review 1A. Sketch and indicate end behavior. So, I would suggest that before you even attempt this, that you will look at it, it's an exponential. So, draw a quick picture of your basic exponential. Because that is the curve that you are starting with, right? That's a picture of y equals 2 to the x. Now, let's look at 1/2 to the x. Isn't 1/2 2 to the negative first? So that is 2 to the negative x. What does changing the sign on x do to the picture? Flip it over the y-axis, which makes perfectly good sense because the original is a growth. Isn't that going to be a decay? So that's going to be that same picture, but going this way. Asymptote's the same, intercept's the same. Nothing changes, just going the other way. Now you're going to take that thing and subtract 1 from it, which means you're going to do what to this picture?
Move it
You're
down.
going to move it down 1 unit. So it's like you have a big pair of scissors, cut it out, paste it down. So, instead of the asymptote being at 0, the asymptote is now at -1. Instead of the intercept being at 0, 1, it's now at 0, 0. And it's decreasing still, so it looks like this. So the purple is a picture of the equation. Now, indicate the end behavior. End behavior is this. So you are just asking yourself, what happens to the curve, the purple curve, as we take the x's toward infinity? Okay? Well, what happens to the purple curve as we go to the right? We're getting closer to -1 from the top of it. We're coming in from the top, as opposed to something like this, which would be coming in from the bottom. Now, what happens as we go to the left, the other direction? What's my purple curve doing? Going to infinity, shooting up into the air. So there is your end behavior for the purple. All right, Sarah L.
Can you do number 4H on the calculator review?
Calculator review 4H. You did one of these yesterday, or whenever it was I saw you last. what formula are we using? All these word problems, it's gonna be PERT. Anytime it's not money, it's gonna be PERT. And in fact, it's PERT in a money problem if the interest is compounded continuously. So PERT can be used in a money problem, but only if the interest is being compounded continuously. All right, so this is 800, right? So find the half-life. All right, that means that if I start with 10, I'm gonna end with 5 after a period of 5. That would be the half-life setup, right? Why don't I just solve that? Because there's too many variables. So then I look on in the problem. It says 2/3 decomposes in 11 years. Now, this can be tricky. Oh, I think before I had an A there, not a Y. Doesn't matter. But what do these two stand for in this formula? A is the amount that I
Have left.
end with, and P is the amount that I
Initially.
start with. So, I have no idea how much I'm starting with, but I'm gonna start with 3. How much will I have left?
2.
1. Because 2/3 decomposes. So if 2/3 has decomposed, that leaves me with 1/3. Are you following? Now read those words carefully. So if I start with 3, or start with whatever you want, but you end up with 1/3 of it. E to the R11. Now, that is not gonna give me the half-life, but it's gonna give me R, which then I can plug in here and find my half-life. So, divide by 3. Let's leave that 1/3, let's not round that off as a decimal. Now we'll take the natural log of both sides. So ln 1/3 is gonna equal 11R. So ln 1/3 divided by 11, negative 0.099. Now I'm gonna hold on to that, that's my R value. And back to my half-life, I'll divide by 10, there's my half for half-life. I'll ln both sides. So the natural log of 0.5 equals RT. So T will be the natural log of 0.5 divided by this number right here. So ln 0.5 divided by second answer. Oh Lord, I somehow pressed a couple other buttons while I was swinging around. So let's see, do it again. I got 6.94 years. Okay, so sometimes this has happened with these and it's happened when you saw a coin. We can't always, in our first equation, get what we want. Sometimes you have to do a little background work. All right, somebody who hasn't asked a question today. Okay, Josh?
4A.
4A on the calculator. Population of Nashville is this and this, and population is decreasing every year. What was population in 1990, and when will population be, this is this, okay. All right, so here we go. The population, I'm gonna start by finding 1990. I do not know what the population is in 1990, I'm gonna figure that out. but I know that it started out, its initial value was, look at that, aren't I tricky? What's that? Yeah, awesome. And I know that it is decreasing 1.5%. So what is its, what's its percentage number that's gonna go in here? Yeah. No, not negative, no. 0.985. How did we get 0.985? Subtract from 1. Remember, 1 is the number that if you multiply by it, nothing changes. If you want things to go up a certain percentage, then it's 1 plus. If you want things to go down a certain percentage, then it's 1 minus. But everything starts with 1. Why am I so adamant that we not put a negative number in here? Because that could produce a negative answer, and does a negative answer even make sense in this problem? No. It's never a negative here. Exponentials, when you're gonna raise something to a power, it's gotta be positive. Because otherwise it won't be exponential, it'll be some weird thing like that. All right, now, this is a yearly number here. It decreases 1.5% every year. How many years am I waiting? 40. So I'm just gonna type that in. 314,159.985 to the 40th. I got 171,632 people. Second part, when will the population be 1111? Well, now I want this to be 1111. And I am solving for X. How many years? So what do I do first? So 111 divided by 314,159 equals 0.985 to the X. Anytime your variable is an exponent, unless you can get a common base, you're going to need logarithms, right, to solve that. So I'm going to take the log. And that's going to equal X log 0.985. I really don't want to write all this out again. I'm going to take this logarithm right here and divide it by that logarithm, right? And that's going to be my answer. Well, it's going to be almost my answer. Why do I say it's almost the answer?
Because
I got 68.77.
to add it to 19.
So I have to add that to 1950 because it says, when is it gonna happen? So it's gonna happen sometime in 2018. Would you agree with that? So we gotta make sure after we do all the math that we actually answer the question. All right, somebody else who hasn't asked one yet? What do we got? You already asked one.
Just a quick question, it's not like a full thing,
What?
it's just, like, for a problem like this, could you not use per?
Could you use PERT? The problem with PERT is it's continuous growth and this is per year. So I think you're looking at the population each year, so I think this is the best way to go.
So per is just more like half-life or continuous?
Any kind of continuous growth. and a population, I get it, it's a little confusing, a population is continuous growth. So if you use per on this, your answer isn't gonna be exactly what this is, but it'll be close, and I would be okay with that. All right, Tess, you got a question this time?
Can you do 1A
On what?
on the
Okay, are we looking at the calculator part or the no calculator part?
just the regular part?
No calculator part. Already did it, Tess. Are you talking about on the review?
Oh,
Already did it. You're 0 for 2. Zoe. What? 3D on the no calculator. So 3D on the no calculator. Zoe says, I think getting the calculator, Mrs. Wood. Well, let's solve it and see. So what would we do first if we were gonna solve this? Add 2. And then divide by 3. And then recognize that the base here is E. And you can log roll this and get E to the third equal x plus 2. E to the third is x plus 2. And then subtract 2, so x equals E cubed minus 2. That's perfectly okay. Okay? Now, remember how sometimes when you were doing like area circles, sometimes they had you type it in your calculator and get a decimal, but sometimes they had you leave it as 49 pi or whatever. Same thing here. All right. So that's fine. That would be the answer without a calculator. All right. Who else? Anybody now? Nobody's raising their hand. Sabrina? 4A on no calculator. 4A on no calculator. So log 1 over the 5th root of 1,000. All right, a couple of things. First is radicals and logarithms do not coexist nicely, all right? They do not get along. So anytime I am in logarithm land and I run into a radical, I'm going to think of it as an exponent. So this is the log of 1 over 1,000 to the 1/5. Would you agree with that? And then I see this 1 over. Well, 1 over means that before it was 1 over, it was a negative exponent. So this is the log of 1,000 to the negative 1/5. The base on this logarithm is 10. So I can approach this 2 different ways. First of all, what's 1,000 relative to 10?
10 cubed.
10 cubed. So this is the log, base 10, of 10 cubed to the negative 1/5. So it's the log base 10 of 10 to the negative 3/5. And we have a property of logarithms that says when these two match, that's it. And the answer is negative 3/5. So that's one way to do it. Another way to do it is to come back here, where we were right here, and set it equal to x. Trying to figure out what it is, equals x. And then log roll it and say 10 to the x equals 1,000 to the negative 1/5. And then 10 to the x equals 10 cubed to the negative 1/5. You see how I'm going to get the same answer? So it's however you want to approach it from that standpoint. But if it's no calculator, kids, you gotta find a way to get these to match, right? If they don't match, you need logarithms, and that's tough to do without a calculator. Oh, I did it, because I did all these problems without a calculator, but it is tough to do. Right? There were no calculators when this was in school. All right, what else? Come on, what else? Josh?
5A.
Non-calculator, 5A, says write in terms of common laws. What are common laws? Common laws are base 10. So this happens to be a log base 3 problem. And we want to change the base. So the change of base formula tells us it's log 19 over log 3. And that could be ln 19 over ln 3. It could be log base 7 of 19 over log base 7 of 3. That will change it, whatever base you want. Whatever base you want. Mr. Fagan.
Can you do calculator view 4, number 4 for J?
Yeah. A pan of brownies, okay. What formula am I going to need for this problem? I'm gonna need Newton's law of cooling. I'm gonna give you that. So I am gonna snag one of my papers. I'm gonna give you. So Newton's law of cooling says this. Now, I'm going to give you that formula along with PV and FV, but that's it. I'm not telling you what any of this stands for. So you need to have practiced to know that. So, a pan of brownies cool from 120 degrees to 80 degrees after 21 minutes in a room that is 24 degrees. Stop right there. Let's put all that in. Where do I put the 120? That's the initial temperature. Think of it, it doesn't stand for original, but think of it as original temperature. Okay? So that's 120. Where do I put the 80? That's this. This is 80. This is the temperature after a given time. So this is 80. 21 minutes is going to be the time, right? So I'm going to do that. What do I do with the 24 degree room?
It's the medium.
That's the temperature, the medium in which I'm existing. Okay? So I pulled brownies out of the oven and put them on the counter. Now they're in a room that's 24 degrees. That's 24. That's 24. And the time we said was 21 minutes. Now, this is like the half-life problem. This is going to give me, okay, it isn't going to answer the question, because the question says, how long is it going to take the brownies to get to 30 degrees? So won't I ultimately be looking for a time? But in order to find it, I need my head. So I'm going to do this first. So 80 equals 24 plus, what is that, 96? So how do I solve that?
Subtract 24.
Subtract 24, so that's gonna be, watch my arithmetic, 56, is that right?
Yeah.
And then I
Divide
will
by 96.
divide by 96,
And then do natural.
and then do natural log of both sides. So the natural log of 56 over 96 equals negative 21k. So k is going to equal, I'm going to go ahead and type it in, even though it is not the answer, and I'm not going to write it down. I'm gonna go ahead and type it in on my trusty calculator. I got .0256. Someone else get that?
I got that.
Okay. Now, to answer the question, I need to use this formula again. How long will it take the brownies to get to 30? Where does the 30 go? Temperature at a given time is 30 equals 24 plus 120 minus 24 e to the negative kt. Nothing else has changed. Weren't the brownies originally 120 degrees? Isn't the room still 24 degrees? That hasn't changed. So I'm going to do all the same math again. So subtracting from 4, this time it's 6. So 6 over 96. Okay, so what's going to happen? We're going to ln both sides, right? So now the natural log of 6 over 96 is going to equal negative kt. Right? So how do I get my answer? I'll divide by second answer. ln, I can't on my calculator, you guys can. Divided by negative second answer. I got 108.
Yeah.
All right. What's the unit on that? 108.02 watts. Minutes? Yep. So 108 minutes. All right. One more test. Annual percentage yield. So that's how much you would make. That's what your interest rate would be if it were compounded once a year. Yes. Well, annual, yeah. All right, here's the deal. I have one more review day penciled in. But I also have the chapter 4 notes sitting right there ready to go. So, tomorrow, or when? Tomorrow? Thursday, we're scheduled to review it again. But if you come in and it's clear to me that you haven't practiced, that you haven't put any time into this, then we're done reviewing and we're going to do chapter 4. So it's on you. If you want to review, put together some productive questions.